How are you? Very good morning. After conducting the laboratory test, you have done it in the practical class itself. Right? Virtual laboratory, we have done CBR test and we have seen all limitations and importance of the test and how it is utilized in the design, etc. etc. We will see now resilient modulus. Resilient modulus, it is the measure of its elastic behavior determined from recoverable deformation in the laboratory test. Recoverable means it can be brought back. The modulus is an important parameter for design and the performance of a pavement. The relation between resilient modulus and the effective CBR in MPA is equal to 10 multiplied by CBR. That is for CBR value 5. If CBR value exceeds 5, then resilient modulus and the effective modulus of resilient is equal to 17.6 multiplied by CBR whole to the power of 0.64. Okay. MR is equal to resilient modulus of the subgrade soil. The CBR of the subgrade should be determined as per IS 2720 part 1636 at the most critical moisture conditions likely to occur at the site. What is design? I have already explained sufficiently by giving an examples. Design of pavement includes the number of layers, its composition and thickness for the selected material to support the traffic load safely without failure. That is the design. In that way the design should be done such that failure should not take place and at the same time it should support the oncoming traffic load very effectively and it should be transformed up to the subgrade soil and to the earth's crust uniformly and smoothly. Okay. Various cases in the design. The flexible pavement with different combinations of traffic loads and material properties. Granular subbase and subbase, cementitious base and subbase with aggregate interlayer, cementitious base and subbase with SAMI, wrap aggregate over cemented subbase, cemented base and granular subbase. All these three are new technologies which are emerging in the present scenario. Earlier, nothing of such kind. Only the conventional methods of CBR method of design was used. Now in order to incorporate all these recent research developed methodologies are incorporated in the design. Problem statement. One problem we will see how the design is carried out. Design the pavement for construction of a new flexible pavement with the following data. 4 lanes divided national highway for which we have to design. Design life is 15 years. Data collection, material properties. What are all the various properties which are obtained in the laboratory for the soil? California bearing ratio CBR, resilient modulus MR, modulus of elasticity E, poisonous ratio mu. The CBR values are calculated after every kilometer on selected stretch. That is important. Every kilometer of 10 kilometer having the same type of soil. Suppose the values obtained are 3.8, 2.8, 4.5, 3.9, 4.2, 2.9, 4.7, 4.3, 4 and 4.6. For example, these are the values. Based on the collected data, the design CBR, that is 90th percentile CBR, is calculated as below. How it is calculated? Here. Arrange in ascending order. So whatever the data collected, you put it in ascending order. That means 2.8 to 4.7. Barabar? 2.8 is the minimum value and 4.7 is the maximum value. You see, 4.7 is the maximum, whereas 2.8 is the minimum. We are putting in ascending order. Calculate the percentage greater than equal to the value as follows. For CBR of 3.8, percentage of value is greater than equal to 3.8 is nothing but 8 divided by 10, because there are 8 values, multiplied by 100, 80%. Similarly, for 2.8% is 100%, 4.5 CBR is 80%, and so on. Now, a plot is made between percentages of values greater than equal to the CBR values versus CBR as follows. This is the curve. Result, the 98th percentile CBR value is 2.9%, 90th percentage. You have to come down. That gives you 2.9. Okay? So in this way that is calculated. Effective CBR. This is as per IRC 37 2012. You have to plot this graph, effective CBR. So you will find out the effective CBR from the graph. Poisson's ratio. Mu is defined as the ratio of lateral strain to the axial strain. Lateral strain over axial strain caused by the load parallel to the axis along with the epsilon A is measured. It is found that for most of the pavement structures, the influence of mu is normally small. It has been observed. For most of the cement treated materials, that is soil cement, cement treated base, lean concrete, and PCC, the value of mu normally lies between 0.10 and 0.25. Usually for concrete, what we take? For concrete, we take it as 0.15. Unbound granular material lie between 0.2 to 0.5, and those for bituminous mixers range from 0.35. Elastic modulus of various pavement materials are obtained either through tests or through the recommendations available in the guidelines. Repeated flexure or indirect tensile stress tests are carried out to determine the dynamic modulus ED of bituminous mixers. Resilient modulus is the measure of its elastic behavior determined from recoverable deformation in laboratory tests. The behavior of the subgrade is essentially elastic under the transient trophic loading with negligible permanent deformation in a single pass. This can be determined by laboratory by conducting tests. Calculation of MR for subgrade. How? The resilient modulus is calculated as below. MR in MPa megapascal is equal to 10 into CBR, that we have already seen for CBR 5. If it is greater than 17.6 multiplied by CBR whole to the power of 0.64, already we have seen as per IRC 37 2012 guidelines. So it is to be scrupulously followed. Whereas traffic count you have to take, assessment of average daily traffic should be normally based on 7 days. I have been saying from the introduction class. In accordance with IRC 9 traffic census on non-urban roads, classify traffic into different categories such as two-wheelers, three-wheelers, passenger cars, trucks, etc. But only commercial vehicle with laden weight greater than 3 tons is taken into consideration for the design. Commercial vehicles are further categorized as single axle, single wheel, single axle, dual wheel, single axle, tandem axle, dual wheel, and tandem axle, dual wheel. Where no traffic count data is available, data from roads of similar classification and importance may be used to predict the design traffic. So sometimes it may be possible that actual or factual traffic count data may not be available. In that case, we cannot stop the work. Then what we should do? Similar classification and importance may be used by previous history or records so that we can predict the design traffic for the present case. Calculation of design factor, that includes design traffic, axial load survey, vehicle damage factor, VDF, and lane distribution factor, LDF. Design traffic, initial traffic after construction in terms of number of commercial vehicles per day, CVPD, commercial vehicles per day. Traffic growth rate during the design life in percentage, design life in number of years, spectrum of axial loads, vehicle damage factor, distribution of commercial traffic over the carriageway. These are all self-explanatory. You are at V level. Certain things should be on your head. You should feel that you yourself can understand many things. For our case, because it is only in a syllabus, it may not be possible to complete by the teacher by explaining each and every bit of things. Okay? My students can understand that. For our case, the number of heavy commercial vehicle per day is taken as 7-day average for 24-hour count comes to be 2792 vehicle per day as per the last count for this case. A is equal to P into 1 plus R to the power of X. P is equal to 2792 CVPD, commercial vehicles per day. R is equal to 7% as I have said. And X is equal to 10 years. A is equal to 5000 CVPD. Result. Traffic in the year of completion of construction is 5000 commercial vehicle per day in both the directions. Axial load survey. Required for VDF calculation and fatigue damage analysis of cementitious base. The axial load spectrum is formulated by considering 10 kN, 20 kN, 30 kN intervals for single, tandem and tridem axial respectively. I have shown along with the sketch tridem and tandem. Result. As per the study, the percentage of single, tandem and tridem axial are 45%, 45% and 10% respectively. So axial load spectrum, that is the calculation part. You need not have to remember. Vehicle damage factor, VDF. The formula to calculate VDF is given as, in exam, if VDF is asked, you have to write this formula. Somehow you have to remember, no other choice. And you have to put the values and get the answer. So what it is? VDF is equal to V1 whole multiplied by W1 by WS whole to the power of 4 plus V2 W2 by WS whole to the power of 4 whole divided by V1 plus V2 plus etc. Here also plus etc. W1 and W2 are the mean values of the various axial load groups. V1, V2 are the respective traffic volumes. WS is the standard axial load. That's why suffix S. Suffix S stands for standard axial. W, we know, always it is load. Standard axial load for single axial, tandem axial and tridem axial is 80 kN, 148 kN, 224 kN. We have seen this as per IRC 37 in the tabular column around 5 to 6 PPT back. Page 7. In IRC 37 2012, you will see this, that is being copied and pasted here. Result, the VDF for single axial load, tandem axial load and tridem axial load is 4.11, 8.37 and 7.51. Vehicle damage factor, VDF. Where sufficient information on axial loads are not available, where or when ऐसा होना चाहिए था, WHERE होना चाहिए था, WERE हो गया, that's all. This should be taken as where sufficient information on axial loads are not available, or the small size of project does not warrant an axial load survey, the default values of VDF may be taken. That is taken in this table. You yourself can read and understand. Very easy. Why should I unnecessarily read and waste my energy and your time and my time? Now LDF. Distribution of commercial traffic in each direction and in each lane is required for determining the total equivalent standard axial load applications to be considered in the design. Single lane road, total vehicle in both the direction you have to count. 2-lane single carriageway, 50% of the total vehicle in both the directions. 4-lane single carriageway, 40% of the total vehicle in both the direction. Dual carriageway, 2-lane 75%, 3-lane 60%, 4-lane 45%. Number of commercial vehicles in each direction. So this is a guideline to be followed as per IRC 1937, 2012, sorry. IRC 37, 2012. Lane distribution factor. Result. In the present design problem, we are given to design a 4-lane divided highway. It is asked in the problem. That is the problem statement. Therefore, the lane distribution factor is 75% of number of commercial vehicle in each direction. Million standard angle. Standard axle. MSA. How to find out? The design that is denoted by capital N. The design traffic is calculated in terms of cumulative number of standard axle of 80 kN carried during the design life of the road. So N is equal to 365 multiplied by 1 plus R to the power of N minus 1 divided by R multiplied by A into D into F. R is equal to 7.5%. N is equal to 20 years. Expressway and urban roads 15 years. National highway and state highway. In this problem we have to design national highway taken N as 15 years because it is given in the problem statement. Am I right? A is 5000 CVPD we have calculated in both the direction and 2500 in one direction because for both direction 5000. Therefore for each direction or one direction it is half of it 2500. Calculation of million standard axle. Single axle load N1 45% vehicles are of single axle. A is equal to 0.45 into 2500, 1125. F is 4.11. N1 is equal to 33.06 into 10 to the power of 6 milli standard axles. Tandem axle load N2, 45% vehicles are of tandem axle. A 0.45 into 2500, 1125. F is 8.37. N2 is equal to 67.33 into 10 to the power of 6, that works out to be 67.33 milli in standard axle. Okay. Calculation of again continued. Total MSA is equal to N1 plus N2 plus N3, 33.06 plus 67.33 plus 13.42. Total will be equal to 113.81. That is almost rounded off to 150 million standard axles approximately. Result, the cumulative million standard axles to be considered for the design is 150 MSA. Okay. References. IRC 37 2012 guidelines for design of flexible pavement. Second revision IRC 37 2001 tentative guidelines for design of flexible pavement. Based on that, all these calculations and theory part is done. Thank you very much. We'll stop here. Okay. Goodbye. Thank you very much. Bye. Have a nice day and keep study. Don't forget. As much as you can, you start practicing. Then only you will get everything intact. Okay. Thank you very much.